Okay, so in this video we're going to have a look at equations of circles, and specifically we're going to look at the equation of circles that are not centred at the origin. So you're going to have a good understanding of your GCSE level equations of circles, which again I'll link in the description below, and also we're going to build up to these type of questions on the screen here, whereby we're going to have to use a bit of completing the square as well. So you're going to have to be okay with both of those topics, but again I'll link them both in the description, so make sure you've obviously looked at equations of circles and you've had a look at completing the square, because we are going to involve both of those topics within this topic here that we're going to actually have a look at. But this is what we're going to build up to here. We're going to have a look at an extension question beyond this as well, but we're going to get started on our first little bit of this. We're going to have a look at why the equation of a circle is what it is and how we go about actually using it. So there that is now. Okay, so before we have a look at answering any of these questions, we're going to have a look at how the equation of a circle is actually derived. Now we know from GCSE level that the equation of a circle that's centred at the origin is x squared plus y squared equals r squared, but this ever so slightly changes when it's not centred at the origin. And we'll have a think about this in terms of a diagram. So if I was to draw a circle, I'm just going to draw a little basic sketch, and we imagine that the circle is over here. Now that centre is obviously not at the origin. Let's call that centre there coordinates A and B. Now if I pick a coordinate that is on the circumference, and hopefully you already know how closely linked this is to Pythagoras, if I pick a coordinate that's up here somewhere, obviously they'd both be positive, but let's call that coordinate x and y. We'll just have to think about how we would find the radius there using Pythagoras. And if I draw my radius in, and I draw a little right angled triangle as we've done at GCSE level, and I have a look at how I would work that radius out, I just need to have a look at the two lengths of the triangle. So obviously we have the change in x down here, which we can have a look at. Now in order to work out that length there, I would take the higher coordinate, which is the x coordinate there, and I would subtract this a coordinate, which is also the x coordinate. So to work that length out there, I would do x, whatever that number is, and I would take away a. And that would be the first length there. Likewise, I would do that for the change in y here, which would just be that y coordinate, which we've labelled y, and I would subtract this y coordinate here, which is labelled b. So I would call that length there y minus b, or whatever you call the centre point there, which I'm going to use a and b throughout this video. Now in terms of actually going about working out the radius there using Pythagoras, we would do this length here squared, and we would add it to this length here squared, and then obviously working out the length of the radius we'd also square root it. But if I just plug those into the equation of a circle, obviously x being first, y being second, as that's what we've used before, we would have the x minus a, that length there squared. We would add to that the other length, the change in y, which is y minus b, again in brackets squared, and that would tell us the radius squared. And that right there is the equation of a circle, and that's what we're going to go about actually using throughout this video. So that right there is a really important equation. I'm going to be using that in pretty much every single question throughout this video, and obviously just thinking about the development there from GCSE maths and where that's come from, and the fact that obviously we didn't need to use the minus a and minus b before, because as it was centred at the origin on those particular questions, we didn't necessarily need to write that it was x minus 0 and y minus 0. So instead we just wrote this equation up here, which is x squared plus y squared equals r squared. But now these circles are not centred on the origin, we are just going to have to use this development of the circle equation a little bit further. But there we go, that equation there is going to be very important. We're going to be using that throughout the video, so make sure you've got that written down, and we're going to have a look at our first question. So for this question here, it says a circle C has centre 3, 1 and passes through the point negative 2, 5. Write down an equation for the circle. There's lots of different ways that you can approach this. I'm going to talk about two different ways on two different questions, then you can decide from there which one you prefer. But here we go. In terms of actually the equation of the circle, I'm always just going to write that down. So I've got x minus a, which is the first coordinate, or the x coordinate within the centre, squared. Add to that y minus b, which is obviously the y coordinate of the centre, squared, and that's going to equal the radius squared. So if we plug these numbers in that we've been given, 3 and 1, let's just put them into the equation. Let's see what we get. So there we go, we've got x minus 3 squared, add y minus 1 squared, and that is equal to the radius squared. Now I'm going to do this in two different ways. So if you've seen this before, you might have only used one of the ways, so I'm going to show you the both. But in terms of what we'd have done at GCSE, maybe at this point, we'd have imagined these two coordinates. Okay, so if I imagine the point 3, 1, which is the centre, it does always help if you can draw a little diagram of these, but if we imagine 3, 1's the centre, and then negative 2, 5, let's just have a little think, it probably looks something like this. There we go. And negative 2, 5 is somewhere over here. Let's have a think. Negative 2 5s maybe over there somewhere. There we go. But in terms of looking at these 2 points, we would find the length of the radius by using Pythagoras, like we've just talked about, and we would look at the base or the rise and the run there, or the change in x and the change in y, and then we just use Pythagoras to work out the radius. So in terms of the base length, it goes from negative 2 on the left there over to 3, which is a length of 5, and going up it goes from 1 up to 5, which is a length of 4. So you can use Pythagoras to work out the length of the radius there, and we can just do that quite nice and easy. We can do 4 squared plus 5 squared, which is 16 plus 25, which is 41. And then you can just square root that for the radius. So r equals the square root of 41. There we go. But obviously we want to know what the radius squared is. So when it's in a nice little square root like that, we can just take away the square root and it'd be 41. So we could finish off our equation here. It'd be x minus 3 squared plus y minus 1 squared equals the radius squared. The radius is root 41, so 41. And there we go. That's obviously one way to go about finding the radius and finishing off your equation. There is another way that I'm going to use in the next process, so you can decide obviously from there which one you prefer, but that is pretty much you know, all we need to do to go about one of these questions here. So let's have a look at another one. Okay, so a very similar question here. We've got a circle C has centre 3 minus 1 and passes through the point 0, 3. Write down an equation for the circle C. So let's have a look then. Obviously the equation for our circle is x minus a in brackets squared plus y minus b, again in brackets squared, and that equals r squared. Now again, we've been given a coordinate for the centre here. So if we plug those in, let's see what we get. We get x minus 3 in brackets squared plus y, and we've got to be careful here because it's y take away minus 1, so that's going to become y plus 1. And again, that's squared, obviously, because that y coordinate there is negative, it flips the symbol there, so it becomes positive 1. And again, that's going to equal r squared. Now, the other way of finding our radius here is we can just plug this coordinate in now. We can just plug that into that equation, and it will tell us what r squared is. So if we slot that in, let's have a look, 0, 3. We're going to put that in, so we get 0 minus 3 in brackets squared, so that's just going to be minus 3 squared. We've got 3 plus 1 in brackets squared there. 3 plus 1 for our y coordinate is 4, so 4 squared, and that's going to tell us our value of r squared. So negative 3 squared is 9, 4 squared is 16, and add them together is 25. And there we go, and that is our value of r squared. And obviously from there we can find out what r is. If we want the radius, we could square root it. It tells us that r equals 5. But obviously for the purpose of this question we are just writing down the equation, so we're just going to use that 25 there. So finish it off just by sticking the 25 in place of r squared and writing your equation. So we get x minus 3 in brackets squared plus y plus 1 in brackets squared equals 25. And there you go, there's the equation of your circle. So there we go, 2 different methods. Obviously this one's a little bit quicker. You can just sub the coordinate in on the centre there, but it is important to know that process of Pythagoras because it's used quite a lot in terms of the higher end questions here. But in terms of these nice little quick ones, you can just plug it in to find your value of r, and then obviously write your equation using that value. But there we go, there's a couple of questions. Now here's a few for you to have a go at. Okay, so here's 2 questions, so pause the video there, have a go, we'll go over the answers in a sec. Okay, so for this first one then, now the coordinates for the centre are 2, 5. So we have x minus 2 in brackets squared plus y minus 5 in brackets squared equals r squared. Now I'm just going to go for the substitution method because it's a little bit quicker. So I'm going to substitute this point in. Let's see what we get. So 5 and 9. So 5 take away 2 is 3. So we've got 3 squared. Add 9 take away 5, which is 4 squared. And let's see what that equals. That's 9 plus 16, which equals 25. So there we go. The radius is therefore the square root of 25, which is 5. But we're just going to put that in place of r squared. And there we go. That's the end of our question. So we get x minus 2 in brackets squared plus y minus 5 in brackets squared equals 25. And there we go. That's that one finished. On to our next one. Let's have a think then. We have our centre point as 5 minus 2. So if we put that in, we get x minus 5 plus y plus 2 this time, because it's take away minus 2 squared, and that equals r squared. There we go. So putting in our points, our centre point there, what's our centre point? It's 1, 5. So if we sub that centre point in, we get 1 minus 5, which is negative 4 squared. Careful to put your negatives in brackets. And then we have 5 plus 2 squared, so 7 squared. And that's going to equal the radius squared in this case again, which we're going to figure out. Negative 4 squared is 16. 7 squared is 49. And if we add those two together, we get 65. So there we go, finishing off our equation. Obviously we just need to plug that value back into there where r squared is, and that will give us an equation which is x minus 5 squared plus y plus 2 squared. There we go, equals 65, and there's our final answer. Obviously you could find the radius as well. You could do the square root of 65, but obviously we're just finding the equation of the circle here, so we don't need to go about doing that. There we go, that's how we're going to find the equation of a circle. Obviously when we have a point for the centre, and we also have a coordinate that it passes through on the circumference. Let's have a look at our next question. Okay, so this question is similar to the one that I showed you at the start of the video. So it says the circle C has equation, and then we have the equation here in lots of pieces. We've got x squareds, y squared, x, y's and a number, and it all equals 0. It says find the coordinates of the centre of C and the radius of C. And then we've got another question here that says find the coordinates of the points where C crosses the y-axis. So we'll have a look at that in a sec, but this actual equation here has to be rearranged in order for us to get it into the format that we want. Obviously we know what the format looks like. We've got x minus a in brackets squared, and then we've got y minus b in brackets squared, and that equals r squared. So we have to rearrange this. We need to get all those numbers on the right hand side, and then we need to get these x parts into brackets. And if you hopefully recognise this, you should recognise that this looks very similar to completed square form, and this is where we're going to use a bit of completing the square to get it into this format. Now if we have a look at the pieces that we have in our equation, we've got some x pieces here. We've got, and I'll highlight this in that colour there, we've got the x squared and we've got a minus 6x. Now if we just forget about everything else there and we group those together, we'll have x squared minus 6x. Okay, now if we were to complete the square on that, okay, just on that part there, we would obviously halve the coefficient of x, so it would be x minus 3 in brackets squared. And obviously if you're not sure on completing the square, don't forget I've linked that in the description below, so check that out first. And then obviously we need to get that back to 0 because there's no number after this. So to get that back to 0, thinking about what that would expand to, well, negative 3 times negative 3 would give us positive 9. So I'd also have to take away 9, and that obviously that expression there would give us x squared minus 6x. So that's just writing that in completed square form. We also have the y pieces. Now if we have a look at the y pieces in there, let's just highlight those. We've got y squared and a plus 2y. Now if I put those in, we've got, so I'll put a plus here as well, we've got y squared plus 2y. Now if I complete the square just on that, and let's keep the plus there as well, we would halve the coefficient of y, so I'd get y plus 1. There we go, in brackets squared. And when we expand that, that gives us plus 1, so we have to take that 1 away to make it balance to the expression above, the y squared plus 2y, and that would obviously complete the square on that part. So far, what we've done, we've completed the square there, that's given us a little bit below, and we completed the square for the x parts there, again for that bit below as well. Then we've still got that minus 15, so I need to bring that minus 15 back in. There we go, and it all equals 0. So let's add the minus 15 in. There we go, and that all equals 0. Now if we have a look at just the numbers that we've got there, we've got a minus 9, a minus 1 and a minus 15. Now if I group those all together, and I'll probably skip a few steps on the next question here, but if I group all the numbers together and I'll put them all at the end, let's see what we've got. We've got x minus 3 in brackets squared plus the y plus 1 in brackets squared. And then all of those numbers, we've got minus 9, minus 1, that's minus 10, minus another 15 is minus 25. There we go, and that all equals 0. And obviously just to finish this off, we just need to move that 25 over to the other side, and that'll get it into the equation of a circle, the format that we've looked at throughout the video. So if we plus 25 to the other side, just to finish this off, and then we can get the centre and the radius from that. So we've got x minus 3 in brackets squared plus y plus 1 in brackets squared, and that equals 25. Now from there we can get the coordinates of the centre, and we can also get the radius. Now the easiest part there, well, I think they're both relatively simple once you've got to this point, but it's nice and easy just to square root this number at the end to get the radius. So we know that the radius is going to equal the square root of 25, as that is r squared at the end, equals the square root of 25, and in this case that becomes a whole number, that becomes 5. Okay, obviously the square root of a number is positive and negative, but we can't have a negative radius, so it's just going to be 5 there for the length of the radius. Now in terms of actually getting the equation of, the coordinates for the centre, now obviously we know it's minus a and minus b on these parts here. So a is going to have to be that 3 right there, so the centre. There we go. We know it's going to be 3. We've taken away 3. And on this one here, we just need to be a little bit more careful because we've got a plus 1 there. So we must have taken away negative 1 in order for it to turn into positive 1. And there we go. That's our radius and our centre taken from that equation. Okay, so there's our two key parts for part A. We've got our radius, which is 5, and our centre, which is 3 and minus 1. Just need to be careful there when there is a positive number in the bracket, like the y plus 1, that you remember therefore it must have been negative 1 that we took away in order for it to become positive. Now the second part here says find the coordinates of the points where C crosses the y-axis. Now in terms of actually thinking about this logically, in terms of a coordinate graph, if we had a circle, let's think about what this would look like. Let's have a think. The centre is at 3 minus 1, which is somewhere there. And if I was to draw a circle in, which I always don't really like doing on the screen here because it's not the easiest to draw, but it would look something, and it's a really rubbish circle, but there we go. It looks something like that if I was to draw a basic sketch. Let's get rid of that centre point because that really does not make it look good. There we go. Let's imagine the centre. There we go. 3 minus 1. Not to scale, but there we go. We have these two coordinate points where it crosses through the axes, so here and here. Now the logical thing about this question is that any point on the y-axis there, the x coordinate down here is always going to be 0. So effectively, if we want to know what the y coordinates are, where it crosses through the y-axis, all we have to do is sub in x equals 0. Let's get rid of that sketch there because it's a little bit of an embarrassing sketch. There we go. But just to give you a sort of an idea as to what we're actually looking at, we're looking at when x equals 0. So if I sub that into my equation, and my equation's there, I just want to know what does it equal when x equals 0. Let's put that in. So when x equals 0, what do we get? And I'm subbing it into this equation just here. So we get 0 minus 3 in the first bracket, so we get negative 3 squared, plus, we don't know the y coordinates, so we've got y plus 1 squared, and that equals 25. So we just need to rearrange this. Now negative 3 squared is 9, so actually I could just think that that's 9 there. And if I take away 9 from both sides, we get y plus 1 in brackets squared equals 16 when you take away that 9. Now if I square root both sides, obviously we want to get y, find out what y is. So square root both sides, we get y plus 1 equals this plus and minus the square root of 16, so it could be plus and minus 4. And obviously then we just need to take away 1 from both sides, and we get y equals minus 1 plus and minus 4. And that there will give us two values, okay, because you could have negative 1 add 4, so y could equal 3, or we could have negative 1 take away 4, which would equal negative 5. So we've got 3 or minus 5 in terms of where it crosses the y-axis. They are the two coordinates there. So obviously you could draw a bit more of an accurate sketch now you know where it crosses through the y-axis. But there we go, that's how we're going to go about solving these two parts of the question. We're going to have a look at one now where potentially those y-intercept points are not whole numbers. So let's have a look now. Okay, so this is a question you saw at the start of the video, and it says the circle C has equation x squared plus y squared plus 4x minus 2y minus 11 equals 0. It says find the coordinates of the centre again, the radius, and then obviously where it crosses through the y-axis. So we'll start by getting this into the equation of a circle. So we've got x squared and a 4x. So if we write that down, we've got x squared plus 4x, and we need to complete the square for that bit. Now you can write this all out in one go if you want, and in fact, let's do that. Let's just write out the y squared and the minus 2y as well, and we'll complete the square in a sec. So plus y squared minus 2y, and then we've got the minus 11, and that equals 0. It's completely up to you. You could even move the 11 over now and deal with that in a sec. But there we go, let's complete the square for the first bit. So our coefficient of x there is 4, so we get x plus 2. In brackets squared, that'll give us 4 at the end, so take away that 4 to make it balance, plus, and then we'll complete the square for this bit. The coefficient there is minus 2 for y, so that'll be y minus 1, which when we expand it gives us 1, so we'll take that 1 away. Then we've got minus 11, and that all equals 0. So just need to move all those numbers to the other side. So we've got -4, -1 and -11. And in total, that adds up to make -16. We've got -4, -1 is -5, -11 is -16. So if we add that to the other side, that'll give us 16 on the other side if we add them all over. So we get x plus 2 in brackets squared. We've got the y minus 1 in brackets squared, and that is all going to equal 16. So there we go, we can go about actually getting the centre point and getting the radius here. Again, we've got the 16 at the end, so the radius equals the square root of that. So the radius equals the square root of 16, which equals 4. So there's our radius. And then we can get our centre points again. We've got one centre point here and another one here. And again, one of them's positive, one's negative, so just watch out. So our centre, there we go. We've got the first coordinate is positive there, so that must have been negative. So there we go, so -2 obviously is -a, so that becomes -2. -2 is, sorry, take away -2 is +2. And then the other one there must be +1, take away b, so take away 1, +1, and there we go, our centre is 2, 1. So there's our first two parts there again. We've got the centre is -2, 1, and the radius there is 4. Now again, we're just going to find those coordinates where it crosses over the y-axis, and again, to do that, we just know that x equals 0. So if we plug x equals 0 into our formula, into our equation there, and we'll see what we get. So let's pull this up, and we get 0 plus 2 in brackets squared to start with, so that's 2 squared. There you go, plus, and then we've got y minus 1 in brackets squared, and that equals 16. So obviously, let's just solve this. So 2 squared is 4. And if we take that away from both sides, we get y minus 1 in brackets squared equals 12. We can square root both sides, so we get y minus 1 equals plus and minus the square root of 12. And then add the other one over here, over to the other side. So we get y equals 1 plus and minus the square root of 12. And there's our two solutions there, or our two coordinates where it crosses the y-axis. Obviously, there's other ways that you can write the answer here as well. Sometimes it might even ask you to write this in its simplest form, this third here. And obviously you can do that as well. Square root of 12 is root 4 times root 3. So you could even write that as 2 root 3. So we could write y equals 1 plus 2 root 3, or y equals 1 minus 2 root 3. There you go, just depends on how the actual question is asking you to give the answer, but obviously thinking about that and writing thirds in its simplest form as well throughout this topic if we can. But there we go, that's how we're going to approach these questions. So there's a couple obviously to practice, and here's a couple for you to have a go at. Okay, so here's your two questions, so pause the video there, have a go, and we'll go over the answer in a sec. Okay, so for the first one, we've got x squared minus 6x up there, so we've got x squared minus 6x, and there's our x pieces, and then we also have y squared and a minus 4y. So we've got plus y squared minus 4y plus the 4, and that equals 0. There we go. So if we complete the square on the first part, we get x minus 3. There we go, halving the coefficient there, which is 6 squared, take away 9. And then we've got plus y minus 2, halving the 4 there, take away 4. And then plus 4, and that all equals 0. So if we get those numbers now, we've got the minus 9, let's just highlight these, we've got minus 9, minus 4 and plus 4. Minus 4 and plus 4 cancel each other out anyway, so we just need to add that 9 over to the other side, and we end up with x minus 3 in brackets squared plus y minus 2, again in brackets squared, and that equals positive 9. So getting our coordinates here then, our centre points, we've got minus 3 and minus 2, so no worries there in terms of the actual symbols there. But we've got the centre, which is going to be 3, 2. And then the radius there, which is the square root of 9. So the radius equals 3. There we go, radius equals 3. So in terms of obviously then making sure that we get the coordinates where it crosses the y-axis, we know that that's when x equals 0. So if we plug that in at the top there, and we get, let's just do it here, x is 0, so we get minus 3 in the start there, squared, plus y minus 2 squared, and that equals 9. There we go, obviously this line below actually we're looking at. There we go, so if we put that all in then, minus 3 squared is 9. So if we take that away from both sides, this is a bit strange. There we go, let's have a look, see what we get. We get y minus 2 in brackets squared equals 0. Square root both sides, we get y minus 2 still equals 0. And there we go, add 2 over, we get y equals 2. So there we go, there's only one coordinate there where it crosses the y-axis. So in terms of actually thinking about what that actually means, if there's just one coordinate where it crosses the y-axis, then the y-axis must actually be a tangent to the circle. Or in other words, without drawing a perfect sketch, it would look something like that. There we go, not a very good circle, but there we go, it would be a tangent to the circle there, that y-axis. So just bear that in mind, it doesn't necessarily have to have two coordinates where it crosses through, but in this case, there we go, we just had the one coordinate there. But there we go, there's the first one. Let's get rid of all this working out. And there we go, so we can have a look at this next one. There we go, so y equals 2, and there's the final part for our question there. Let's just move that over there. Okay, so for this next one, let's see what we've got this time. Right, so we have x squared plus 4x. So let's just group those together. So we have x squared plus 4x. And then what do we have in terms of the y's? We have y squared and minus 6y. So plus y squared minus 6y. And then we've got the minus 2 and it all equals 0. So if we complete the square on those x pieces there, we get x plus 2 in brackets squared. Take away the 4 that's going to expand out to. Plus, and then we've got the y minus 3 in brackets squared, take away the 9 that's going to expand out to, take away 2, and that equals 0. And then moving all those pieces onto the other side then, we've got minus 4, take away 9, which is minus 13, take away another 2 is minus 15. So if we add that 15 to the other side, and that'll give us our equation then, so we get x plus 2 squared plus the y minus 3 squared, and that's going to equal 15 when we move all those numbers over. So there's our equation. Obviously we can get our centre now and we can get our radius. So our radius is going to be the square root of 15. So there we go. We've got our radius equals the square root of 15. And then the coordinates for our centre we've got up here. So we've got the plus 2 and the minus 3. So the centre equals, and then we've got negative 2 for the x coordinate to make sure it's plus 2 in the bracket there, and then we've got 3 for our takeaway 3 there in our other part. So there we go, we've got our centre, we've got our radius. Obviously we've got a third radius in terms of this one, it's the square root of 15. Now we're just going to have a look at finding out where it crosses the y-axis. So in terms of where it crosses the y-axis, obviously again we know that x equals 0, so we just need to sub that coordinate into our equation. So we've got our equation there, let's just get rid of this so we can do it up here. And if we sub x equals 0 into there, for this first bracket here, look, we're going to get 2 squared plus the y minus 3 squared, and that equals 15. 2 squared is 4, so if we take that away from both sides, we get y minus 3 in brackets squared equals 11. Square root both sides, and we get y minus 3 equals the square root of 11, and that's going to be plus and minus. I've not actually left myself enough room for the plus and minus, so let's write that again. Y minus 3 equals plus and minus root 11, and then add the 3 over, and we get y equals 3 plus and minus the square root of 11. There we go, and we can obviously write that as two solutions there. We can say y equals 3 plus root 11 or y equals 3 minus root 11. But there we go, there's our two questions. Let's have a look at a little bit of an extension here in terms of where this can go and how much more complicated this sort of topic can get. Okay, so for our final question, we've got quite a lot to look at, and just as a little pre-warning, this is quite a long one and we've got quite a lot of steps in here. As we can see, we've got parts A, B, C and D. So we're going to focus on one part at a time, and let's have a look at this question. It says A, which is negative 6, 0, and B, which is 2, 4, are the endpoints of a diameter of the circle C with centre Q. And it wants us to find the coordinates of Q. Now obviously if A and B are the endpoints and they are the diameters, the centre of the circle will be at the midpoint of that diameter. And it does help on this type of question here, particularly when there's a lot of parts and a lot of elements, to be able to draw a little sketch of this. Now I'm by no means going to be able to draw a perfect sketch here, but I'll do my best to draw a little bit of a sketch so we can have a look at what this might look like. Now if we draw a little sketch of an axis and we have a think about this, we've got 2 points that are the diameters. So we've got negative 6, 0, which would be somewhere over here, let's imagine. Let's say that's minus 6. And we've got 2, 4, and let's imagine that is over here somewhere. Let's have a think. Oh, I'm going to get this drawn there. Okay, so our centre is going to be somewhere along that line. Let's just imagine it's there for now. Might help me to draw this. But if we draw a little sketch of this circle, and don't worry about it being perfect. Mine, as you're going to see, by no means is going to be perfect. But there we go. We've got something that looks like that. Now my centre point there is no good anymore. But if we kind of imagine maybe it's somewhere here. Okay, so we've got a little sketch of it drawn, and we've got our coordinates on here. So let's label which one's which. We've got A, which is over here. There we go, and we've got B, which is up here, and that coordinate there is 2, 4. There we go. And we've got a circle which is called C, and it's got centre Q. So this point here is Q. And we're going to have a look at working out that coordinate for the first part. So we're looking at part A to start with, and that is find the coordinates of Q. So finding out the coordinates, or the midpoint of a line basically, is nice and simple. All we need to do is add together those coordinates and halve them, and we will find out what that midpoint is. And obviously this over here, this A piece is a coordinate as well, negative 6, 0. So if we take the two x coordinates, we've got negative 6 and 2, and if we add those two together, so for part A here, negative 6 add 2 is negative 4, and we're going to halve that. There we go for our x coordinate, and the other one there we've got 0 and 4 for our y coordinates, so 0 and 4. And if we add those together, we get positive 4, and again we're going to halve that, and that's going to give us our coordinate of our midpoint there, which will be the centre of our circle. And that's what it's asking for there, where it says the coordinate of Q. Obviously over here it says centre Q. So there we go. If we actually work those out, negative 4 divided by 2 is negative 2, and 4 divided by 2 is 2. So there we go, there's the coordinates of our centre. And we can label that now on the diagram, negative 2 and 2, just with our centre point there. Now for part B, the next bit here, it says find an equation for C. So obviously C is the name of the circle, circle C, and we're going to find an equation for it. So let's have a look at going about doing that. So for part B, obviously we know what the equation of a circle looks like. We've got x minus a, now which of that is negative 2 there, so that's going to be x plus 2, as our x coordinate of the centre is negative 2. That's going to be squared, plus, then we've got y minus 2, again in brackets squared, and that equals the radius squared. So we need to figure out what the radius is. And obviously we've got two coordinates on the circumference of the circle, so we could substitute either of those into our equation to figure it out. I'm just going to go for the coordinate 2, 4 here, just to avoid using negatives there. Not that it matters because we're going to square them anyway. But if I sub those coordinates into the equation, we get 2 plus 2 in the first bracket, so that's 4 squared, plus, and then we have y minus 2, so 4 minus 2 is 2, so plus 2 squared, and that's going to equal our radius squared. So 4 squared is 16, 2 squared is 4, and 16 plus 4 is 20. There we go, so 20 is going to be our radius squared. And we can just write that into our equation. There we go, so 20. And there we go, there's part B, our equation for C. Now obviously from that we know the radius is the square root of 20, so we can write that in as well, just so we have our radius ready if we need it at a later point. So then we've got part C here. So part C says, a point P also lies on the circle C. Given that the length of the chord AP is 8 units, find the length of the shortest distance from Q to the chord, so from the centre to the chord. So it says a point P lies on the circle, and the length of the chord A to P is 8 units. Now this is quite an interesting little part of this question here, but let's have a look. Now it doesn't really matter where we put this point, it doesn't really sort of dictate that, it just says that it's 8 units away. We know the radius is the square root of 20, the square root of 20 is somewhere between 4 and 5, so 8 units is going to be longer than the radius. So let's just pick a random point, let's imagine it's over here. There we go. So let's call it that one there, and let's call that point P. Now it says that there's a chord A to P, so A to P over there, and it says that that's 8 units long. Now this brings in a little bit of circle theorems as well, and let's just move that Q out the way so we can see this a little bit better. Let's just relabel that, there we go, Q. But in terms of the chord, okay, obviously the shortest distance from Q, the centre, to the chord is via the radius, or essentially just going straight down towards the circumference of the circle and through that chord. Okay, so obviously that there forms a right angle, and we're going to be using that circle theorem there, where the chord forms a perpendicular bisector with the radius, or the radius perpendicularly bisects the chord. And we're going to be thinking about that as we go through this. But in terms of this, it says P lies on the circle C, and it says given that the length of that chord is 8 units, find the length of the shortest distance. So essentially what it says is that full length of that chord, the one that I've drawn in orange, is 8 units, and therefore as it's been bisected, both sides of that must be 4 units. Okay, so we know that either side of that we've got 4. Now in terms of actually going about this now, we just need to think about what piece of maths we can actually use to go about solving this. So we can actually use a little bit of Pythagoras to do this, or potentially using some SOHCAHTOA, and actually thinking about how we go about it. So let's just draw a little right angled triangle in. So from point A up to Q, there we go. In fact, hold on, what's it actually ask us for? The length of AP, find the length of the shortest distance from Q to the chord. So we're looking for the length of this line here from there to there that I've just highlighted. So we can draw this in. If we draw this in here, there we go. We've got a radius, we've got that length that I've highlighted in orange, and we've got the orange one, in yellow, and we've got the orange line there, which has a length of 4. And we know that it's a perpendicular bisector of the chord, so we know that's a little right angled triangle there. So if we come away from the diagram for a second and I draw this out, let's have a look. We've got a right angled triangle. There we go. We've got Q sitting there, we've got A sitting down here, and then we've got the point where it bisects, obviously in the bottom right there, where that right angle is. Now at the moment we've got some of the lengths. We've got this length here, which is 4, and we also have the length of the radius, which we've got up here. We've got root 20. So we know that this length here is root 20. There we go, and we're trying to work out the length of this line just here. So straight away we can just use a bit of Pythagoras to do that, and obviously that's going to be nice and easy for us. So for part C, we're going to do the hypotenuse squared, which is going to be 20. There we go, and we're going to take away, as we're looking for a shorter side, this length here squared. So take away 4 squared, which is 16, and that's going to give us the length that we need to square root. So 20 take away 16 is 4. So obviously we just need to do the square root of 4, which equals 2. There we go. So that length there is 2, and that's our final answer for part C. Obviously we've got no units here, it's just 8 units, it said up here in the question. So it's just 2 units, the length of the shortest distance from Q to the chord. Okay, obviously just drawing in a little right angled triangle there and having that understanding of circle theorems and how that applies to this particular question. But there we go, there's part C. So for part D, for our final part, I did say we've got quite a lot to look at here. It says find the size of the angle QPB and giving your answer to the nearest decimal place. So QPB, let's have a look where that is. So Q's at the centre, P is down here, and B is up there. So we're going from Q to P to B, and we're having a look at this angle just here. There we go. Now this is a little bit weird, but if we were to extend that full diameter that we were told about in the starting question, there we go, we've got another circle theorem involved. We've got angles in a semicircle forming a right angle at the circumference. So from A to B is the diameter, and then we've got this big right angle triangle, which I'll try and highlight here, going down to there and forming this big right angled triangle. Now obviously, if we can find one of those two angles within that right angle, we'll be able to find one of the other two. So obviously looking at this, do we have enough lengths already to find the size of that angle there that we're being asked to find? Now we know the radius is root 20, so we can label that on the diagram. We've got root 20 here, we've got root 20 there. There we go. We don't know the length of B to P though, it doesn't tell us anything about that, so we don't know that. And do we know the other length? We know this one here is root 20, I've got that one, root 20 there, but we don't know any of the other lengths or any of the other angles. We've just got those two root 20s with no other angle. What about the other triangle then? We've got this AQP. Okay, if I just sort of see if I can get rid of this highlighted one. There we go, almost. There we go, let's just redraw that line in. There we are. What about this one here? How much do we know within this triangle? Because potentially we might be able to find the other angle there sitting in the right angle. Well, we know all the lengths on that triangle. We've got the root 20, we've got the root 20, and we've got the length of 8 units along that orange line. So we can definitely work that out using the cosine rule, or we could think about it in terms of, and let's just highlight this, we could look at just this little right angle triangle here. Again, we've got a base of 4, we've got a hypotenuse of root 20. It's just a right angle triangle like the one on the other side. So we could just use SOHCAHTOA just to work out the angle within that. Completely up to you at this point. You could use either cosine rule or you could just use SOHCAHTOA. I'm going to opt for using SOHCAHTOA, just think it's a little bit quicker. I don't think I'm going to be able to get rid of that highlighter, so we're going to have to leave that there. So let's draw this to the side. Let's have a look at that. Let's get rid of this part C triangle here and have a look at this one now. Okay, so we've got the right angle triangle there, where it's going from Q down to the little right angle there that we haven't got a point on. We've got a little cross with the X there, and then we've got point B, P over here, and we're trying to find the size of this angle here, and then we can take it away from 90 to get the size of the other angle. So let's have a look. We've got 4 down the bottom, and we have root 20 on the hypotenuse. So we've got the adjacent and the hypotenuse, so we can do cos minus 1 A over H. Remember, for your trigonometry, there we go, CAH. So cos minus 1, A is 4, so we've got 4 over root 20. There we go, and if we type that into a calculator, let's see what we get. Shift cos 4 over the square root of 20. There we go, and we get 26.565 degrees. Right, let's have a look then. So that comes out as 26.565, a few more decimals, degrees. And obviously that's this little angle just here. Okay, so we could label that on the diagram if we want, just there, 26.565. But obviously we want the one just next to it. And the one just next to it, as we've said with circle theorems, is what makes it up to a right angle. So I just need to take away that 26.565 away from 90. So 90, take away 26.565. There we go. If we do 90 minus answer on the calculator, we get 63.434, or 435 if we round it to 3 decimal places there. And the actual question was asking us to give it to 1 decimal place. So our final answer here for part D, there we go, to finish this off, is going to be 63 point, and that rounds to 63.4. There we go, 63.4 degrees. Right, there we go. So that was a massive question, a lot of stuff. Let's just have a quick run through of what we've done there before you have a go at this. We had part A, finding the coordinates of the centre of the circle, obviously just doing midpoint of a line there, adding together the X and Y coordinates and halving them. Then we had part B, finding the equation of the circle, which we've done throughout this video. So we just obviously did the centre point there, and then found the radius by subbing the coordinates in. Hopefully those bits were nice and simple. And then we had part C here, where we were asked to find the shortest distance from the centre to the chord, and we used a bit of circle theorem knowledge there, knowing that the chord gets bisected by the radius, and just using a bit of, we used Pythagoras for that part, didn't we? So just drawing a right angled triangle and using Pythagoras there to find a shorter side. And then our final part, we had to find the length of the size of an angle. And again, we just used a bit of SOHCAHTOA with the other right angled triangle on the other side there. And obviously a bit of circle theorems, knowing that the angle at the circumference in a semicircle is a right angle, and obviously found half of that so we could find out the missing gap. So there's an awful lot of maths going on in that question. I did warn you, it was a long one, quite a tricky one. It does require you to be able to draw a little sketch here. I think that'd be very, very difficult if you weren't able to draw a sketch in this question. So that is a sort of big element to this, is actually just being able to draw a sketch. So I've got one for you to have a go at. Obviously, big thing there is to be able to draw the sketch. Obviously parts A and B should be fine with, obviously if you're happy with the rest of the video. And then parts C and D here is our sort of extension part. But if you're able to draw the diagram, you're able to get a decent picture drawn down, you're able to get a general idea of where these right angle triangles are, hopefully you can have a good go at this. But here we go, here's one for you to have a go at. Okay, so here's your final question to have a go at before we finish. So have a read through all of these, see how far you can get, see how many of these you can actually get towards an answer for. So pause the video there, have a go, we'll go with the answer in a sec. Okay, so let's have a look then. So we've got some slightly higher numbers in this question. We've got some slightly higher numbers in terms of the coordinates as well. So we've got the two coordinates here that are, it says, are the diameter. We've got P and we've got Q. It says given that that's the diameter of circle C, find the coordinates of A, and it says that's the centre this time, so we've got centre A. So let's have a look then at actually go about drawing a sketch for this. Even though we don't need it for part A, just like to get that sketch out the way as early as possible. So we've got -9, 8 and 15 minus 10. So we've got some quite large numbers here. Obviously we're not going to draw it to scale, but 15 minus 10 is somewhere over here, and negative 9, 8 is somewhere up here. There we go. So in terms of our actual circle there, which I'll try again my best to draw in, we've got something that looks like that. There we go. So in terms of actually going about drawing this then, let's label these points. So we've got P up there, which is negative 9, 8. We've got Q over here, which is 15 minus 10. There we go. And obviously we're looking for that centre point there, which is A, which we need to find out before we can probably label that on the diagram. So let's have a look then. So part A, we'll add together the two x coordinates. So we have 15 add the negative 9. 15 add negative 9 is 6. So we have 6 divided by 2 for our first x coordinate. And then we've got 8 add the negative 10, which is negative 2 for our y coordinate, and we're going to halve that. There we go. So for our midpoint there, we get 6 over 2, which is 3, and negative 2 over 2, which is negative 1. So there we go. There's our centre point, 3 minus 1. So that's going to be somewhere here, and it's going to be slightly off centre there in terms of my diagram. But there we go. It's just a little bit of a sketch. So there we go. We can always draw that diameter in as well. So if I go about drawing that diameter in, it's not going to be perfect, but there we go. Looks something like that. And let's label on that coordinate as well. So the centre is called A. There we go, and that has the coordinate 3 minus 1. There we go. So there we go, that is a little sketch that we've got for our diagram. Now for part B, it says find the equation for this circle. So for part B, this bit's okay again. We've got x minus 3 in brackets squared plus, and then our y coordinate in the centre, we've got y take away minus 1, so y plus 1 in brackets squared, and that equals, and we'll find the radius now. So if we sub the coordinates into the radius, one of these points on the circumference, doesn't again matter which one we go for. Let's just go for the negative 9 and 8 maybe. Doesn't actually matter, let's just pick one. In fact, let's just go for the 15 minus 10. Okay, so subbing those in, 15 is our x value, so we've got 15 take away 3, which is 12, so we've got 12 squared, plus we've got y plus 1, so negative 10 plus 1 is negative 9, so negative 9 squared. Well, that's 144 plus 81, which is 225. There we go, so 225. And the square root of that for the radius is 15. There we go, that's quite nice, actually comes out as a nice whole number. But there we go, that's 225 for r squared, and there's the equation of our circle. Okay, so for part C, let's have a look. So let's read this carefully. It says a point R also lies on the circle, and given that the length of the chord PR is 20 units, find the length of the shortest side from A to the chord PR. So again, we can just pick a random point for this to go somewhere, and let's just have another quick read. It said the length of the chord P to R, so let's put it down here. So P to R, there we go, and that's 20 units, it says. So in terms of obviously the chord that is joining up to that from the centre there, it's not going to be a perfect diagram here, but we've got a chord joining up to it from there, again forming that right angled triangle. So this is R, there we go, and we are going to work out that distance just there. So it says the chord is 20 units, so we know that both halves of that are both 10, so 10 and 10, and we know the radius is 15, so that length there is 15. So we've got this nice right angled triangle here that we can use to work it out. So if I draw that separately, just to have a look at part C here, we have this right angled triangle that we've got drawn in. We know that this length here is 10, this length here is 15, and we're trying to work out this distance down the bottom, so we can use Pythagoras for that. So we can do 15 squared, the hypotenuse, take away 10 squared, one of the shorter sides, and that is 225, take away 100, which is 125. Obviously just square rooting that to finish it off, we get the square root of 125. Now that's not the nicest, but there we go. We get the square root of 125. Or to be fair, we could actually simplify that third. That is 25 times 5. Square root of 25 is 5, so that could also be written as 5 root 5. There we go. It does say, just here, give your answer in its simplest form. There we go, so we do need to simplify that as well. So 5 root 5 is that length there. Okay, so let's get rid of that on the diagram because I didn't put 5 root 5 there. Let's just relabel that as 5 root 5. There we go, 5 root 5. Okay, so that's that part C done. Now we can have a look at part D. So this final part of the question here says find the size of the angle ARQ, giving your answer again to the nearest decimal place. But there we go, we're going to find the size of angle ARQ. So A is the centre, R is over here, the new point we've just put on, and Q is over there. So let's just join that up, A to R to Q, and we're looking for the size of this angle just here. Again, that forms our angle at the centre, angle at the, in a semicircle. So we've got an angle at the angle at the circumference in a semicircle. So we've got a 90-degree angle just there. And again, let's just have a look at this triangle on the right here, this little one that we're trying to find the angle in. We know that the radius there is 15, so we know this length just here. We don't know the length of R to Q, but we do know A to Q, that's 15 as well. But there we go, we don't actually have enough information to get the angle in that particular triangle. So coming back to our other triangle then, PAR, we can definitely find this angle here. So if we find this angle first, we can do that nice and easily because we've got a nice right angle triangle drawn in there. Obviously the right angle triangle we used in part C, it's just mirrored onto the other side, it's actually an isosceles there. But there we go, if we redraw that triangle to the side, just have a look at that. We have 10 down the bottom. We've got 5 root 5 here, and we've got that the hypotenuse there is 15, so we can use any bit of trigonometry here or SOHCAHTOA to work out that angle, but we're trying to work out this angle just here. There we go. So if we just go for using cos again, and I'll use the adjacent, which is 10, the hypotenuse, which is 15, then we can do, and let's just get rid of some of this, we've got cos minus 1, adjacent over hypotenuse, so 10 over 15. Let's just type that into the calculator, see what that gives us. So shift cos 10 over 15, and that gives us 48.189. There we go, so that one there is 48.189. There's a few more decimals after that, but we're not going to worry too much about that, as it only wants it to one decimal place. And then there we go, we can work out the angle next to it, because they both have to add up to 90. So 90, take away 48.189. So look, I'll do that on a calculator, 90 minus answer, 41.8 to one decimal place. It comes out as 41.810. There we go. So to finish that off as our final answer, we'll round it to one decimal place. So for part D there, our final answer is 41.8 degrees. There we go. And that's our question finished, and there's a lot of maths going on in that question there. Obviously a bit of an extension, as I mentioned at the start, but a lot of different bits of maths. We had circle theorems, we've got trigonometry, Pythagoras, you know, midpoints of a line, equations of circles. You got everything in there, so it's a massive question, a lot of marks. You know, something like that would be 8 to 10 marks potentially, around about the 8 marks. But there we go, that is the end of equations of circles that aren't centered at the origin. And there we go, hopefully you found that useful and helpful. If you did, please like, please comment, please subscribe, and I'll see you for the next one.